I shouldn't stand in front of there. Thank you all for coming to the second talk in this session. With us now, we've got Rhys and Mathieu, who are going to be talking to us about Django at Admiral. So please join me in giving them a warm welcome.
Hi there. Thanks, everyone, for attending. Today, we'd like to talk to you about how we use Django at Admiral, in particular on the Veygo team. So the Veygo team's been going for the last 2 years. We'll discuss our journey. We'll tell you about the initial MVP product, the challenges we face currently, and then the future and what we anticipate for the future. So I'm Rhys. I'm a software engineer at Veygo. I've been working on the team for just over a year now.
And my name is Mathieu. So I work at a company called Theodore, and we've been working with Veygo from the start, so almost 2 years now. So today's talk can be broken down into 3 sections. We'll take you on a journey from the initial MVP product, scaling the then customer-facing websites, and the problems we anticipate in the future, and how we plan on overcoming them. So first, a really short backstory. So in 2016, first, for those of you who don't know, Admiral is an insurance company based here in Cardiff. And in 2016, so they got kind of worried about the incoming disruptions to the car insurance market, with the young people having the tendency to not own a car anymore, and the rise of the app-hailing ride like Uber and the self-driving cars, all of which would cause big issues for the current insurers. So they decided to invest into digital products in order to try to reach these new markets or maybe even create new ones. So this is how Jean-Baptiste and Rohan decided to launch a new product within Admiral for the temporary car sharing insurance. So targeting people who do have a driving license but do not own a car, but having one available and wanting to drive it occasionally. For this, so they created a small structure within Admiral, mostly independent structure with full control over the product, the processes they wanted to use, and they decided to try and build the products with the agile and lean methodologies that are successful at a lot of startups. This is a phrase that really sticks with me from the first time I read it. If you're not embarrassed by the first version of your product, then you're launching too late. What this means is you should really focus on what makes you and your product special, instead of having to release something that contains every single feature that you want, that you wish for, and release these features to the market as quickly as possible. What it is not is an excuse to release a really crappy product where half the features are broken and where the user experience is really horrible.
So when we talk about MVP, we mean the minimum viable product. And everyone knows Elon Musk. He's the guy who's trying to get people to Mars. But sending people to Mars is difficult. It is rocket science, after all. So he's approached it on a step-by-step, iterative basis. His first product, he didn't have any ambition of it actually reaching Mars, but he would give him and his team an invaluable insight into space exploration and sending satellites and people into orbit. In a similar way, our goal was to enable people who didn't own a car access to a vehicle when they need one. And we wanted to start being useful as quickly as possible. Our early innovation wasn't about a groundbreaking pricing model or incredible fraud detection or even amazing IT infrastructure. It was about focusing on the business problem. Do people want temporary car insurance, and how can we get them to buy it? Similarly to the product, we took an MVP approach to our tech stack. Choosing Django allowed us to use Python, which is awesome. One of the main requirements is to have a functional self-service administration site for our operations team, which we got for free for using Django, and is still being used today. We got to benefit from awesome open source libraries like DjangoRest framework. And to date, it's been pretty rock solid in terms of security. It survived everything Admiral Central IT have been able to throw at it. For the front end, we use React. At the time of the project initiated, it was a major player for single-page apps. We could have potentially saved time by using Django templates, but we had a vision that we would one day have a mobile app, and React allowed us to focus on APIs from day one. And then we wouldn't have to rewrite any of our logic around forms, templates, and keep the views consistent when we would go on to use React Native. So as we mentioned earlier, we didn't want to focus too much or invest too much time into our infrastructure. We run with AWS. They do a great job. Why try doing something ourselves with Ansible scripts or something other such? So we use Elastic Beanstalk for hosting and scaling our applications, and RDS for hosting our databases. In our team, we had basically zero knowledge of network infrastructure and that sort of thing. We didn't want to shoehorn one person into learning that and just keep them away from doing what they do best, development. So AWS helped us just get something out there really quickly and allowed us to focus on what makes it special, building our product.
And then there we are, 7 weeks later, which is actually the target that we set before we started the project. 7 weeks later, we managed to release the first version of the application to the live website and getting actual and paying customers. The first version was really simple. It was basically a form spanned over 4 or 5 pages. You'd go through it, give us all your data that we needed. You'd pay, and after that, get your insurance documents. And that's literally all there was for the first version, nothing more. On top of the kind of technical success of releasing it so quickly, what's also very impressive is that we got the endorsement and the green light from all the other Admiral departments that have a say in whether or not a product can go live, so which are marketing, finance, underwriting, and probably a lot of others. Instead of seeing these guys as kind of a hindrance for our project and showing them the product finished and having to deal with their annoying feedback, we try and involve them from the start, inviting them to the weekly reviews, showing them the product evolve week after week, and making them feel part of the team. The guys from IT security are quite scary, but what we realized is that you can bribe them with a box of donuts to run the pen test a couple of days earlier if you're kind of late for the release. It doesn't work all the time, though. So this was great. The first phase for us was a huge success, but we didn't stop. We didn't stop here. What came next was dozen and dozen of iterations of trying new stuff on the user flow, adding, moving stuff around, and constantly looking at the analytics to see the impact the changes had on the users and the user flow. We also made, of course, a great deal of improvements in the backend services and logic, and starting adding all the features that we knew we wanted on the product, but didn't make the initial 7 weeks cut.
So as well as scaling the product, we were also growing the team. So we initially started with 2 developers working on one team. That quickly tripled in a very short timescale. So one of the challenges is, as the team grows, how do we continue to be as fast per developer as we were initially? We didn't want to overburden the team with heavy processes, but we also want to avoid a single point of failure, that point of failure being 1 or 2 experienced developers. One of the answers was to split the team into smaller teams. So each team would focus on their application. In this time, it was pricing, underwriting, and the quote engine. This would avoid dependencies and clashes between teams. And each team would have full control over their application. This raised another question. How do you ensure consistency across those teams?
So the original team was really small, so basically everyone knew almost everything that was in the code base. So as we grew, as Rhys said, this couldn't continue. So we kind of had to introduce new kind of standards. The first is around testing. So we had a pretty decent test strategy and coverage on the initial application. And every time we onboarded new developers, we kind of showed them these tests, explained why we thought they were really important to us, and then trusted them to apply the same level of standards on whatever application they would be working next. So we didn't actually enforce anything on this at first. We're now trying to experiment with code coverage and are pretty happy with the result. Something else that we try to introduce to maintain a coherent code base is a linter. For the backend Python code, we chose PyLint. I don't know how many of you have tried to introduce a linter, especially a pretty harsh one like PyLint, on an existing code base. It's not easy every day. Basically, if you try and introduce it at once on the entire code base, depending how big it is, you're going to spend a couple of months only fixing PyLint issues. So we decided to introduce it little by little, So the entire rule set, but only on the files that were actually changed. And we made a game out of it. We called it Pilot Roulette. Every time someone would start a task, you'd never know what file you'd have to change. And sometimes you'd be really unlucky and make a really small change in the massive legacy file. We were the first to change since the linter introduction, and then have the privilege of spending the afternoon fixing all the linting issues in it. Some of the developers in the team still have nightmares about the missing docstring rule. But eventually, I think now most of the files are linted, look really nice, and we're pretty happy with the result. Another big part of keeping the dev team very efficient is automation. So with automation, all the tasks that are adjacent to coding. This means making sure that the linter, the tests are run by CI, deployment make it as easy as possible, even automatic, and basically any other check that you want. Anything that requires human input takes time to set up, understand, and is very error prone, whereas if it's automated, it just runs on its own without any intervention. So the automation is mostly the third part of this slide. And this build process is very important to us. To understand why, you need some kind of small background. You need to understand what the single piece flow is. That's something that came from the Toyota car factories in Japan. And what it means for us is at any point in time, one developer can work on one and only one task. And what we mean by working on a task, it means actually doing the coding, but then also getting the task reviewed, making sure it passes all the automatic checks, and also making sure it's deployed and being able to validate. As long as your task isn't ready to be validated by someone, you cannot start anything else. So it's really important that all this process is very streamlined, because basically, once you're done with the coding, you're waiting for things to happen. And developer time is a really scarce resource, probably everywhere, and every minute counts for us. As the team grew, the build started taking more and more time, and so we started slowly realizing we had a big problem with it. So we started measuring. At peak, I think, so the build were taking on average 30 minutes, and they were failing for random reason more than half the time. So with quick calculation, if you consider that one developer works on around 4 tasks every day, this means that everyone was waiting an hour each day to see his build fail. And this was a big problem for us. And what's really nice about having these numbers available instead of the vague feeling that the build is too long and it's annoying for us is it allowed us to go to the product people, show them in a language that they understood that we did have a problem, and enable them to give us the time and resources we need to fix it. So these are 2 graphs about the build time and metrics. So the dark blue line is the percent of failed builds, which peaks at around 50%, and the other blue line, the light blue one, is the build time, which starts at around 11 minutes. I'll be completely honest, the biggest improvement we've seen in the build reliability was getting rid of the really flaky Selenium end-to-end test suite, which would fail almost half the time because it wouldn't wait for some element to render and consider it wasn't there on the page. Another big improvement we've seen on reliability was making sure that all the developers had the IDE rightly set up with most of the checks that actually run on CI, so mostly the linter, the red squiggly line that comes from Python, that's really annoying for everyone and that you actually want to fix way before it gets to the CI pipeline. Something that worked really well on the time improvement was running only the checks that are relevant to the part of the code that were actually modified, instead of running our entire test suite all the time. We've also tried something that failed miserably. The biggest one probably being coming from a good place, thinking that instead of waiting for the build to do these checks, why not run them on every dev's machine at commit or just before the push? So we wrote small Git hooks to actually run those checks before. This was a huge disaster, and we probably reverted within the day because it was really annoying. It prevented any form of quick whip commit and quick code sharing across the team, and it was really excruciating looking at the terminal waiting for it to commit before trying to move into something else.
So one of the really nice things about Django is the concept of the migration system. So when a new developer gets onboarded, they've already had to learn quite a lot at this point. They've had to learn our tech stack, our methodology and ways of working, and the product. It's really nice to not have to teach them something else again. We'd have to teach them about SQL queries or any advanced SQL statements to begin with. Also, the migrations live with the code, so it's really easy to keep the code and the database schema in sync. That's all great, but it comes at a cost. Not having dedicated people to focus on the database and do specific reviews for database queries opens up a new class of issues. Developers running potentially dangerous queries on live and not knowing about it. As we mentioned earlier, we do have a review process at pull request, which highlights major red flags, but it's not 100%, it doesn't catch everything. So we've had some migrations lock database tables without us realizing. This carried on a little while until one day, one particularly bad migration, locked a core table for half an hour, rendering the website unusable. This was unacceptable, and it drove us to find a solution that wouldn't slow down our development, but would prevent this from happening again. We've done some research online. We found that we were the only ones having the problem. It was a shared problem. We found some examples of problem queries and queries that should be avoided that could potentially lock tables. So we wrote a very simple bash script, which dumps the result in SQL from a Django migration into a big text file, and then parses that file looking for particular bad patterns that we'd like to avoid. This is a build on CircleCI that failed just last week. A developer was trying to do a Django migration that had a SQL statement that's in our banned list, so his build failed. Since then, we haven't had any migration issues, thankfully. But I'd like to emphasize that if a developer's build fails for that particular check, it's not a big red cross, you've done something wrong, you should be penalized. We treat it as a learning opportunity. They can just dig into the script and it's clearly explained why they should avoid doing that particular query, and they're more likely to share it with other developers and not make the same mistake in the future. Sort of like learning from where we've been burnt in the past. I'd like to quickly go over our login and error reporting. So right from the beginning, we've been using Sentry and New Relic. We love Sentry. It was super simple to set up, really quick. And it's great at providing you with metrics on all horrible errors and really bad exceptions. And it groups them nicely by events and the number of users that are affected. This helps us decide the priority and severity of particular errors and when they should be prioritized and fixed. New Relic, we primarily use it for the application health monitoring. It gives us some great insights into how the customer is actually interacting with our system, how long they're waiting on particular sites, and the load across our servers. But at this point, in the early days, it's worth noticing that we didn't have any business alerts. The only way of knowing if our live site had issues or it was down was an angry customer on the phone saying, "What the hell's happening, guys? I can't get a quote. I need to drive my car." It wasn't great. Our solution to that was to implement a very simple status check. It was really easy to set up and worked well in the beginning. The way it worked is it was a SQL query which would look at the last 5 minutes, look at the number of successful requests compared to the number of failed requests. And if the number of failed requests was over a certain threshold, it would just send out an email to the team saying, "Something's broke, guys. Have a look." Remember, we were MVP from the start. So this is a million times better than being alerted by your customers that your site's down. But what we noticed eventually was this query was putting a massive load on the database. Every 5 minutes, we'd see a massive spike as it tried to query the previous 5 minutes. So we had to find a better solution. For a bit of context, up until this point, if we suspected an issue on live, it would involve a developer going onto the AWS console, downloading a load of logs, and trawling through it, just like this example here, perhaps looking for a timestamp of when they thought the issue happened, see if there's any exceptions in the logs or any bad errors. As you can imagine, this is very tedious, and it has such a low success rate, it was hardly worth doing. So we had a feeling that these two issues were linked, the login and the alerting, and that they could be tackled together. So we eventually moved to a centralized logging solution. We used FileBeat for watching all the log files, Elasticsearch for indexing the logs, and Kibana for providing a very nice layer on top for querying those logs. To get the most out of Kibana then, we changed our text-based login to JSON login, allowing you to easily query on fields. And this example on the board here is a real example. I'm querying on the key car reg for a value ABC123, and it pulls back all the events that car was looked up on our site. Once we all had all that in place, we could then benefit from business alerts. We used a tool called ElastAlert. The way ElastAlert works is it makes requests to Elasticsearch, taking in parameters for the frequency of checks and the threshold for sending alerts. It allowed us to completely replace all our SQL queries. This year is one of the many alerts we get fired into our Slack channel of a particular third party throwing too many exceptions within a certain time frame. And that's where we are today. Here we are, 2 years later. We've offered more than 2 million quotes. We've given over 160 people who don't own cars access to a vehicle. And we've grown the team from 2 to 44. This is a recent photo of us, still on top of the world. But again, we're not stopping here. So we've achieved quite a lot already. What are the future challenges we're anticipating?
So you need to remember, we started almost 2 years ago with one simple Django app. Then we grew the team slightly, managed to get to around 3 apps. It was still quite an easy and reasonable task to reason the entire application. The guys who had been there from the start knew most of what actually happened, where everything was. I think today we're probably around here. So probably around here. And we plan to continue growing, and maybe even growing even faster than we have until now. So relying on some people knowing everything won't do for us. When scaling infrastructure, the number of services independent automatically grows, and very soon you start speaking of microservices, which in an ideal world are a very small piece of code that do a very specific task independently, and they work great. The problem, very often, these services need to communicate with each other to get some data from somewhere else, get some computation from somewhere else, and feed the data back in somewhere. And very often, or very easily, you can end up with something looking like this. A huge spaghetti of microservices where no one actually knows what's happening and where. So it takes a lot of time to think and design these even before implementing them. And once you have them, there's a class of tools that enable you to get insight into what's actually happening at runtime. One of these tools is Zipkin. That's the one we tried. So we tried it with 2 things in mind. First, trying to understand the relations between applications within our system, and then also monitoring some specific functions for which we were worried about performance. We were very surprised at how easy it was to actually set up. The code sample you see is actually most of what we had to write to get it to work with one of our Flask applications. The third line here actually wraps the entire app with a Zipkin. So it takes care of sending metrics for every API endpoint. And every fishy function that you want to monitor separately, you only need to wrap in the span annotation, and Zipkin and the boilerplate code provided takes care of everything else for you. What we're even more surprised about is how easy it was then to get a really nice result and insight into it. So getting the UI to run locally with Docker was really easy, completely effortless, and feeding the data into it also worked out of the box. Another problem when you kind of multiply the APIs is you need to remember what APIs are available, what are the endpoints, what are the parameters, what types it expects, and also very important, what you can expect in return. Swagger does a really nice job at doing this. Basically, you write some documentation somewhere, either in their format or in your Python docstring, and something generates this nice UI for you, which allows you to browse and interact easily with the API. This is very nice, but it's documentation. And in the real world, at least in all the world I've seen, documentation never gets updated, and this very quickly becomes obsolete. So there are ways in most frameworks to tie to the code. So remember, we're an existing product. We already have a lot of existing APIs. So we have our Python models and serializer already existing. There are tools that allow us to take these models and generate the Swagger model definition for us. So this is something that we don't have to rewrite. It's really nice.
So The last few slides, we've gone over the problems we envision as developers. But ultimately, the system is driven by the product and how we can best serve the customers. We'll continue being pragmatic and continue to solve problems as they arise, hopefully allowing us to focus on the original business problem, giving people who don't own a car access to one when they need one. Hope you enjoyed the talk, maybe even learned something. If you want to talk to us, learn some more, have a chat about what we've done, especially in the last few slides because we had to fly through those quite quickly. Come and see us in the Veygo stand. We're more than happy to have a chat. And we are hiring, so if on our side. Thank you.
So thank you very much, Rhys, Mathieu. As I said, they'll be around for the rest of the conference. Do go and see them on their stand. We're very grateful to our sponsors for all the support they provide us. And that's the end of this session. So thank you. Please join me in thanking them again.
Thanks.